Hey everybody, welcome to Young Engineers of Today, or welcome back, I guess. Hope you had a good week. Hope you had a good class on Monday with Code Combat, Mr. Dubik, and I hope it was enlightening. We are going to actually jump into more traditional Python programming, but we're going to do it in a little bit of an unusual way. We're going to write like a big, I say a big, we're going to write a small program from start to finish. I'm going to walk you through why we do the things we do. No, we're not going to be doing it on a Raspberry Pi. Not yet, at least. My Raspberry Pi has not yet arrived, uh, it's not up and running yet. So that will be something for next week. But we'll uh, we'll do some traditional Python programming right now, and then we'll move on to Raspberry Pi stuff next week, hopefully. So we'll get that all good to go. It's going to start out though with downloading Python on your home computers because you need to download the Python language, basically the Python translator. It's going to be 3.0 in order to program in Python. Basically, you need to take those commands and translate them into something that the computer can use. So that involves downloading the Python compiler and everything. No, we're not going to be doing code combat today. This is going to be just straight up Python. So here I am at python.org/downloads. If you just go to python.org, you can actually just navigate to it by clicking on the downloads link right here. You don't even have to click anything underneath it, just downloads, and it'll take you straight to here. And then you can click, okay, sounds good. You can click download Python 3.6.3. And it should automatically already detect your operating system. Otherwise, you can scroll down and either check some of the older versions or check one of the other operating systems. But for now, it should be just this yellow button up here that you need. And once you click that, it'll start to download. And if you're installing Python right now, like you don't already have it installed, just go ahead and raise your hand once you've gotten to this area and completed the download. Also, if you already have Python installed, go ahead and raise your hand. No, it's going to be 3.6.3. Yeah. All right, that's most of the hands, but we're gonna wait. Yeah, no worries, Jack. We got we still got a few people who haven't raised their hands yet, which is fine. We'll just hang out and wait for those hands before we continue, so that we know that everybody's on the same page. All right, so that's almost everybody. Basically, just once you download it, go ahead and click on the exe and open it, and it will run through the installation process. Hey, and it's going to install, idle, Python pip, documentation. It's going to create shortcuts and file associations. You can just keep it as the default settings, and that should be okay. Um, it'll ask you if you want to make changes, then it'll run through the installer. Shouldn't take too long. Python's I mean, the base of Python is not that big, standard library. I don't. Python isn't really that big. Um, it's very modular, which is part of the reason why the base library is not big at all. Um, you can import, whatever. It's basically there's a joke that Python supports, time travel. You can just import time travel. Whenever you click on python.exe, it says it's opening, but then it returns to python.exe and nothing happens. Do you have install permissions? Alternatively, you might have like a Windows Smart Screen running or something like that, which is automatically preventing it from opening. Okay, I mean, but things that this involves changing some path files and things like that, which are generally under more protection than, oh, it just was taking a minute to open? Gotcha. Okay. All right. And once you've gotten it installed, um, what we're going to do is we're going to open up idle. So what I'm going to do over here is I'm going to search. And if I just do a search on my computer for Python, you might not be able to see this, but one of the results is idle, all caps, IDLE, Python 3.6, 64-bit. Just go ahead and click on that, and then you should get this. This is the Python shell. We're just going to poke around on this for a minute. So if you don't find it, that's fine. We're actually going to take a different tack to get more of the Python syntax down. So don't sweat it if you're searching for it and you're not sure what to open or anything like that. We're going to do something a little bit different. Okay. All right. So this is, well, the Python shell. This allows you to basically run small little Python commands um, in order to sort of, well, basically use Python, do different things with it. You can It runs like a regular terminal, except it will accept Python commands. So we can say print hello. And sure enough, hello gets returned. You can say var number equals 9. Var number is not correct. So var, why is that invalid? Let's just say number equals 9. Okay, print number. And we get to print 9. Oh, we're not going to do turtle. We're going to do, yeah, that's exactly the one you want to download is 3.6.3. We're not going to do turtle though. We're going to take a bit of a different tack. I know turtle's pretty cool, but We'll write a command line program, or I know. I told you guys to download 3.6.3 though. It's a it's going to be such a small difference between the two that it'll all be okay. Yeah. But like as you can see here, you can just kind of throw in um, small little commands, chain them together. So I created a variable called number and set it equal to 9, and then I told Python to print that number, and 9 got printed out to the console. Pretty exciting stuff, right? Not really, but that's okay. Muy small. We're going to do something a little bit different. So what I'm going to do is I'm going to quit. Oh, whoops. Quit. Run the quit command. Yes, I want to kill it. And we're going to make a program a little bit differently. And the reason why I'm doing this is going to be more like traditional programming in the sense that we're going to write something and then we're going to run it through the operating system as opposed to running something directly through the shell. You don't really, that's not really a programming environment that you tend to do in many many programming and scripting languages. Python is a little bit unique in that sense, and actually Python's very cool in that sense because you can. But we're gonna go a little bit more of a traditional route, and then that way you guys should be a little bit more familiar with running it like other programming languages as well. And if you end up working with Python, then that's fine. You know how to do Python this way, and then you can get familiar with Python shell and be super comfortable with that too, or you can get PyCharm or whatever. So, what this is going to be is this is going to be a guess the number game, and we're going to walk through all the different things that make up this program. We might not finish the program today. In fact, chances are pretty good that we're not going to finish the program today, but that's okay. But we're going to walk through all the things that make up this program so that you guys have a better idea of what exactly goes into it. So what I did is I opened up Notepad. This is just a plain text editor. Um, Different from Word or Office or something like that. Those are rich text editors. Those allow you to do things like bold and italics and make fonts larger and smaller and put in pictures and stuff like that. Notepad doesn't really do that kind of stuff. Like it kind of does that stuff, but then it's no longer a plain text file if you do that kind of stuff. So what we're interested in is just a plain text file. In fact, the it's like a .txt kind of a text file editor. For Mac, I believe it's called WordPad, but then you have to enter it into plain text mode. Um, and I believe there's an option. As soon as the font looks like that, you're in plain text mode. Looks kind of like a sort of like a terminal font. But just we want to make sure that we're making a plain text file, and that's all. You want to open a if Notepad is your only plain text editor, yes. Oh, text edit. Yeah, that's what it is. Thank you. That's yep. It's been a while since I've had a functioning Mac, so I couldn't remember off the format and then make plain text. Thank you. Thank you, Jasper. Yes, so if you're running text edit on a Mac, uh, you can go into format and then click make plain text. Apostrophes don't work in text edit? Yeah, they do. Quotes? Sure they do. I don't know. But that's not normal behavior. The quotes should work. In fact, the quotes need to work because there are quotes used in Python. Yeah, maybe, I don't know. But okay, so uh, Jasper suggests go into format and click on allow hyphenation. Interesting. I'm glad that we've got some resident uh, Mac enthusiasts to help out with the troubleshooting on something like that. It's a lot easier generally when I have a system in front of me that I can walk through with you. So I appreciate the fact that you guys exist. Are you using Notepad? Okay. Yeah, no, Liam. You use Mac? Okay, gotcha. All right, well, yeah, using Notepad, then it should come out of the box as a plain text editor. I just wanted to show you that existed, that Python shell existed, so that you could also run commands through that. I think you got it? Okay, cool. Interesting. Haven't heard of that one before. Gotcha. Okay. All right. So at least most of us should have a plain text editor open, right? Raise your hand if you're still trying to get one open. All right. That's a few people, so we'll give you guys another minute or so. All right. Once you've got, all right. Well, let's just go ahead and get started, since it seems like mostly everybody has at least one open now. So we're going to start with variables. We're going to say we're going to start this program with our variables. So we're going to say guesses taken equals 0. My font's also larger so that it's easier for you guys to read it, um, because it's being sent through an internet connection to your guys' computers onto a smaller screen than mine, by virtue of the fact that it's, in a window as opposed to being full screen like mine is. I'm not making any commentary about, monitor sizes or anything like that. So I make the font larger so that it's easier for you guys to read. So don't sweat it if yours is smaller on your plain text editor or anything like that. There's nothing wrong. So this right here, thinking back to Code Combat, they have what is it? You guys had the one where you had to call a function in order to get an enemy's name. Like when you told the hero to attack an enemy, you called the attack function and then gave it the name of an enemy. But then there was that one level where you didn't actually have the names of the enemies and you had to feed it the enemy variable. And then you had to fill the enemy variable with an enemy name based on calling a function. Well, we're sort of taking a simpler look at variables right now. Variables are all they are, they're just spots in memory that you've given a name to that you then use to hold values, which you can then mess around with later and call back whenever you need to and stuff like that. Variables make it so that your program can do different things to the. Okay, so let's put it this way. A computer is all about manipulating numbers, and that's it. I made it sound like there was more to that sentence because a lot of times people think that there is more to it than that, but that's really all a computer is. I mean, it is living up to its name. It computes. The reason why we have fancy colors on a screen and a mouse and a keyboard that gives us letters and we can send faxes across the world and I mean still inexplicably and we can fly a plane with it and stuff like that is because we have given meaning to those numbers after the computer computes them based on context, based on what we're trying to do. We can say, okay, so every single pixel on the screen is going to be a set of three numbers: how much red, how much green, and how much blue. And we're going to have the computer do a whole bunch of math on every single set of numbers on this screen. When I say every pixel, I mean every single pixel. My cursor right now is this little four-headed arrow thing. That's probably made up of a few dozen pixels. Each one of those has an array of three numbers. Each one of those three numbers, the computer is doing math on. Because my cursor isn't moving, all it's doing is it's changing the color values of the different pixels to make it look like my cursor is moving. That makes sense? Flying a plane, we take different values and throw them into a computer, and we come out with how the plane should turn, or uh, whether or not it should speed up, or whether or not it should, gain altitude or lose altitude, whether or not it should, bank to the left and pitch up in order to make a nice gentle curve across this area. Yeah, we're going to code something. Um, I just wanted to give some background information. So anyway, yeah, variables. Variables store information in memory. Uh, your computer has memory and it has a CPU. The CPU takes the stuff out of the memory, it crunches the numbers, changes them somehow, puts them back into memory. That's really all a computer does. A hard drive is simply more permanent memory. A GPU is simply a fancier CPU. That's all. So a computer just computes. So that's what a variable is. Right now we've declared a variable and we've given it a value of 0. Next we're going to take a variable and we're going to fill it with the value, the result of a function, just like that getting enemy name thing. So we're going to say we're going to have a function, or we're going to have a variable called my name, and we're going to set it equal to the value of input. Now, normally input would work like this. All input does is it waits for the user to type something on the keyboard and hit enter. Input works like this. However, what do you mean no white space in Python? because in actuality, white space is very important in some ways in Python. Things like this, I can put as many spaces as I'd like between lines. However, Python takes into account indentation. Indentation is very important in Python because that determines where things are placed in the code and stuff like that. And we'll actually get into that in a minute. We'll use a loop and we'll throw some stuff into the loop. But there is definitely white space in Python. Python actually takes white space very seriously. It's a part of how it determines how the structure or how the program is structured. That okay. All right. So anyway, input waits for input from the user. Just typing something on a keyboard, hitting enter, and it works like this. However, we are going to fill it with something helpful. We're going to say, "Hello, what is your name?" The reason why we're doing that is because keeping input blank like that, it'll just sit there on a blank line, and that's not very user-friendly. Somebody's just going to run our program, and they're going to sit there, and the program is going to do nothing. It's just going to have a blank line after they run it, because it's waiting for input, but the user doesn't know that. They don't intrinsically know that. So we give it a value inside these parentheses, which is going to be the thing that's put out into the console so that they know it's looking for something. Nice, Liam. All right. So we're going to do another interesting thing. We're going to create a variable called number, and we're going to fill it with a random value. So this is probably actually maybe the weirdest thing that we're looking at here. So number equals random dot rand int parentheses 1 comma 20. I was going to get there, Liam. I was going to do this in bits and pieces, but thank you. I appreciate you looking out for me. So, yes, what exactly is going on here? We're calling a function, just like we did up here with input. We're calling a function called randint, and all that's short for is random integer. And as you guys know, an integer is a whole number. Then we've got the parentheses so that we know it's a function. And what the function looks for is two values. Well, it doesn't need it, but what it can look for is two values. And it tries to give you a number in between and including those two values. So what we're telling it, in essence here, is we're saying, hey, give us a random integer between 1 and 20 inclusive. This random dot bit in front of it means that it is a part of the random library, which libraries are collections of functions and things like that that we can then use to expand upon the functionality of our Python code. So for instance, in like the base C code, there's actually no way to write to a screen. It doesn't exist. There's no print function in base C. That's because you don't assume anything in C. Maybe somebody's running this on a computer that has no screen and has no keyboard to take an input. So it doesn't assume that. So if you wanted something that would write to the screen if you're writing in C, you'd have to write your own functions that would basically translate all of your stuff into functions that wrote to the screen, which is a big pain. Especially if you had to do that for every single program that you wrote. You had to make sure that you wrote a set of functions first that put your program onto the screen for you to be able to see what was going on and took input from the keyboard so that you could interact with it. However, somebody out there wrote a set of functions that does that for us. And they package them into libraries, which are collections of functions that expand your functionality. So all you need to do is you need to import the standard input-output library for C, and suddenly you can write to the screen and take input from the keyboard. So Python is a similar thing. Random doesn't exist in Python. However, we can just go up to the top here and say imports random. So now Python knows, hey, we got to import the random library. So down here, when we get to number, we can say random.randint, and it knows to go to that random library that we're talking about and get the random integer call and to set it to a number between 1 and 20, including 1 and 20. So far, all we've done is we've set up a variable called guessesTaken, made it equal to 0. We've asked what the user's name is and put it into a value called myName, and we've gotten a random number between 1 and 20 and put it into the number variable. So far, pretty straightforward, right? Next, we're going to tell the user our intention. We're going to print out a statement to the console. We're going to say, well, my name, I am thinking of a number between 1 and 20. What is it? So, all right, it's a print call, just like we've seen before, just like you saw in Code Combat before. It's a print call. All it does is it prints something to the screen. But what happened here? What is going on here? So the double quotes, obviously, the double quotes mean a string literal. So whatever is in between double quotes, you print that exactly out to the screen as is without the double quotes. So this is going to, the output on this is going to be something like, well, and then, I don't know what's happening there. I am thinking of a number between 1 and 20. What is it? Like that. But what's going on right here? What is that? I forgot about the comma there as well. Well, what we're doing here is we're saying, okay, my name is going to be a variable. It's going to hold letters and stuff. Presumably, it's going to be somebody's name. So all we're saying is we're taking the contents of my name and we're sticking it in between this bit right here, the well, comma, and the space, and then this bit right here, which is the comma, and then the rest of it. So it should be, well, Thomas, I am thinking of, or, well, Liam, or, well, Aiden, whatever name you type in there. It's going to automatically fill it with the name that you put when it asks you what your name is. The fancy word for this is concatenation, and the plus signs enable that in this print function. The important thing is also that my name right now is presumably going to contain letters. It's going to look like a name. We could break this program and put a bunch of values in there that don't make any sense, but, that would break our program. Let's try not to do that right now. So the next thing we're going to jump into is a loop. We're going to have this while guesses taken is less than 6. So guesses taken starts at 0. And then we got this while loop that's going to say guesses taken is less than 6. And then we're going to put some stuff after it. But what this is going to be, let's say loop stuff here, more loop stuff here. This is just an example. So as you guys know, a loop will run a specific set of commands a certain number of times. In this case, it's going to be a finite number of times. How do I know that? Well, we've got the while, which tells us it's a loop, and then we've got this stuff right here, which could also go in parentheses, but this is basically our logic check. Oop, I forgot the colon afterwards. There should be a colon after guesses taken less than 6. As long as the statement here is true, this loop will continue to execute. So it'll run through, it'll hit here. If it's true, it'll run through the loop once. It'll come back to the top. If it's still true, it'll run through the loop again. It'll come back to the top. If it's still true, it'll come through until this in here is no longer considered true. In this case, as soon as guesses taken is equal to or greater than 6, it should stop as soon as it's equal to 6. But if it's equal to or greater than 6, the loop stuff will no longer run and then we will directly skip to not loop stuff afterwards. So let's populate our loop with something. So while guess is taken is less than 6, presumably this program, you probably already guessed by now, is going to have the user guess what number they're thinking of. So looks like, yeah. 1, 2, 4. The other thing that's important about Python is, like I said before, indentation is very important. So we want to make sure that anything that's a part of the loop is going to be indented by either 4 spaces or a tab. Since Notepad does strange tab indentation, I would suggest using 4 spaces just to make sure that you're running it properly. So while guess is taken is less than 6, we're going to take a variable called guess and we're going to populate it with a user's guess. So guess is equal to input with the prompt guess a number. Then we're going to do something interesting here. We're going to take guess and we're going to make it an integer. What do you think this will, well, okay, so basically, I'm gonna put it like this. Variables in programming are made up of a whole bunch of different types. There can be strings, which hold letters and stuff. There can be integers, which hold whole numbers. There can be floats, which hold decimal point numbers, stuff like that. Whenever a user enters in a value, it's going to be basically a string. It's going to be a collection of letters. Now, confusingly, a string can also be a collection of numbers, but it's going to be numbers that you can print to the screen as opposed to numbers that you can do math within the computer. Think of almost kind of like the distinction between word numbers and numerals. So the difference between 1 and 1, kind of. It's sort of like that. So anyway, what we're going to do is we're going to turn whatever number the user enters into an integer so that we can do comparisons on it. And that's exactly what we're going to do here. So we're going to say, first we're going to say guesses taken equals guesses taken plus 1. And we're going to say if guess is greater than number. Now I hit space 8 times, 4 times for each indentation. And this is going to be a part of this if statement, so we want to make sure it's indented further than the if. I'm going to say print your number is too high. So if guess is greater than the actual number, we'll say that your number is too high. Indented 4 times. If guess is less than number, indented 8 spaces. Print your number is too low. Not really surprising, right? If it's less than the number, then the number is too low. And we've also got if guess is equal to number. This one's interesting. Brick. Okay. So we'll take a look at these 3 ones as well. So these are if statements. If statements are part of something called control flow. Control flow make your program do, and that's just the fancy name for it. You can just think of them as if statements. But they make your program do different things every time it runs based on whether or not the user does different things when they run it, or the values that are held inside of the program are different from run to run. So it allows our program to not run the same way every single time we run it. It's between this and loops and variables and stuff like that, these 3 things all sort of work together in order to give a program interactivity and interestingness to it. Without if statements, our program would run exactly the same every time. And we don't exactly want that. You know, we want to make sure that it responds to the user. So that's why we use these. And all this does is if this statement right here is true. So if guess is in fact greater than number, then execute this statement. If it's not, if guess is less than or equal to number, skip this statement. And then you can check the next one. So if guess is less than number, then run this statement. If not, skip this one too, move on to the next one. And that leaves us with our final one, if guess is equal to number. And notice how I used two equal signs here. I've used one equal sign up here. And generally when you're doing math and stuff like that, if you want to see if something's equivalent, you tend to use one equal sign. So where are we using two here? Well, that's because if we use two equal signs, we let the computer know that we're asking it if these two numbers are in fact equal. If we just used one equal sign right here, we would automatically assign the value of number to guess. It wouldn't actually check, it would just assign the value, which is not what we're looking for. Because if we were to think about how our program would run, the user would input a number. If the number was incorrect, it might say, oh, hey, your number is too high. It would skip this one because the number is not too low. It would get here, and then it would assign guess the value of number. And then it would say, hey, you're correct, because now they're equal to one another, and that's just going to be weird. So we want to make sure that they're the same value. Or we want to make sure that they check if they're the same value, not if they're the same value. We still want to have some challenge for the user. So that's going to be our loop. Every time this loop is true, every time guess is taken is less than 6, we're going to run through all of these statements right here. That's going to be like the main guessing part of the program. Then we're going to say if guess is equal to number. So we're going to say it again. I'm actually going to put another space right here. You don't really need to. You can have one right after the other if you wanted to. This just makes it easier to read in my eyes. So that's personal preference. I will say, however, that you probably want to start getting like good habits with making sure that your code is readable, because as your code gets more, like if you start doing a lot more coding and your code gets more complex, if you don't really adhere to like good practices and making it readable and stuff like that, it's going to be really hard for you to be able to understand what your code is doing later on, or even 3 hours later. You know, it's going to get to be almost unmanageable. So if you make your code easier to read now, then as you get more proficient with coding and you make larger programs and stuff like that, you can handle larger programs because you'll be able to understand what exactly you've written down. Remembering everything you've done is a lot harder than you think. So, if they guess it correctly, then we're going to go ahead and say guesses taken equals string guesses taken. So now we're actually going to do the opposite of what we did up here with guesses taken. We're going to take the number value of guesses taken and we're going to turn it into a string so that we can print it out to the console. And we're going to say, we're going to print good gerb, my name, the number was, oops, oh, whoop, oh, you guessed in guesses taken, guesses, exclamation mark, because enthusiasm is fun, yay. So yeah, what all it does right here is it just says, you know, good job, my name, you guessed in, guesses taken, guesses. Pretty straightforward, right? All it does is it just says you guessed in this number of guesses. Don't really need to explain that too hard. I'm actually going to turn, no, I'll keep word wrap on. That's a good question. I'm probably going to get familiarized with the Raspberry Pi in lab. Let me just hit this one up real quick. We'll just say if guess does not equal number, and that's what the exclamation mark and then the equal sign means. If if this one is not equal to this. It doesn't care whether it's higher or lower. It just wants to make sure that it's not equal to it. We'll say print sorry. Well, first we'll say number is equal to string number. And we'll say print sorry, the number I was thinking of was, and then we'll add number to it and close that out. So this should only run if we break out of the loop, so they've run out of guesses anyway. So we'll just say, hey, sorry, the number we were thinking of was this. But if they get it right, then we say, oh, good job. So this is the program. It's a fair number of lines for like a first program, but it's pretty straightforward, hopefully. What I am going to do, though, is I'm going to save it. And I'm going to save it to my C drive. Don't normally save things to your C drive, but that's what I'm going to do here. And I'm going to name it guess.py. You want to make sure that you give it the .py at the end so that the computer knows that it is a Python file. So I'm going to name it guess.py. I'm going to save it right to the C drive. Yep. I guess I'm not going to save it to the C drive because I am a liar. I'm going to save it to the documents folder. In older versions of Windows, you could directly save it to the C drive, and they don't let you do that anymore. There are actually a lot of things that they put in the interest of protecting the user, and I should be an administrator, but hey, whatever. Anyway, so I'm going to save it to my documents folder, and then I'm going to open up a terminal. And I'm just going to show this to you guys. We don't really have enough time to walk you through the entire process, but I'm going to show it to you guys. All you have to do is you just have to get a terminal open. If you're running the Mac, you can open up terminal. If your Windows is going to be Command Prompt or PowerShell, depending upon your version of Windows. And then all you're going to do is you're going to navigate to your documents folder. And you're going to run guess.py. And it's going to say, hello, what is your name? And my name is Thomas. And then it says, well, I'm thinking of a number between 1 and 20. What is it? Maybe it's 5. Your number is too low, so you have to guess higher. Maybe it's a 9. It's too low. Maybe 15. Too low. Maybe 19. Good job. You guessed in 4 guesses. And that's all this program is. And then it quits out, and you can run it again if you want to. And that's all. It's a fairly simple, straightforward program. I'm going to go ahead and do the poll questions for right now. Since it is 7:50 and I want to make sure that we can leave it open for some question and answer time. If you guys have any, otherwise, you can head out a little bit early. But yeah, once the poll questions are done, if you have any questions, I'm here. Otherwise, you can head out and have a great weekend. And I will personally see you on Wednesday. I will do a little bit more of the Raspberry Pi stuff.